Namaskar, good morning and welcome to the course once again. In this lecture, we are going to cover a very important aspect of this particular course, which is sensitivity analysis. But before that, we would like to recapitulate what we learnt in the last lecture. If you remember, in the last lecture, we covered various evaluation methods for evaluating public projects, which are now, you understand, different from the evaluation of private projects. We understood the concept of benefit cost ratio, and we said that any project qualifies for further round of screening if it passes that B by C criteria of more than 1. We did one example, and with the help of that example we understood all the steps of benefit cost ratio which we have to follow. Now, in this lecture we are going to cover sensitivity analysis. Now, just to give you the background of this particular lecture, you might remember that one of the assumptions that we made for solving all our problems so far was the variable values were supposed to be constant and accurate. So, whether it was incomings or whether it was outgoings, whether it was salvage value, whether it was interest rate, or for that matter whether it was the life of the asset, we assumed them to be constant. However, as you know, in real life situation, these variables may undergo changes. For example, you may find that you might have assumed an annual income of 1 lakh from some investment plan, but it may so happen that instead of 1 lakh now you may be getting 90,000, or it may go to 105,000. Salvage value you might have estimated 50,000, but now you find when at the time of disposal of that equipment you find that the salvage value is coming to be only 25,000. So, we would like to know, because of these changes, is my original decision going to change? We would also like to understand the impact of changes made in one or two variables and their impact on the final decision. So, this is the topic for today's lecture. As I told you, we are going to cover sensitivity analysis. Now, as I told you already, the various variables that we assumed in our analysis so far, for example, the receipts, the interest rate, the salvage value, all were assumed to be constant. They were also supposed to be accurate. But as you know, in real life situation, this is not the case. Some variables fine. For example, at time t is equal to 0, if you are investing something, that is known for certainty, that is going to happen for certainty. But what happens to your forecast for incomes? What happens to your forecast for expense? What happens to your forecast for interest rate? These things are likely to be changing in future. So, we would like to know whether our decisions are going to change, right. So, as I told you further, you can understand that the life of an asset could be either longer or the shorter than the assumed value. The salvage value may be less or sometimes even more than your estimated value. So, if we try to find the objective of sensitivity analysis, basically it is aimed at studying the impact of change in the value of variables. The variables, as I told you, it could be incomings, outgoings, interest rate, salvage value and so on the economic decision. So, decision was, let us say if we are using net present worth and we were finding net present worth of greater than 0, we said okay, we can accept this alternative. So, we would like to know what will be the impact of changes in these variables on the economic decision. Sensitivity analysis is also sometimes referred to as what if analysis. So, it is same as what if analysis. So, we would like to see what happens if I make this variable change from this value to this value. Say for example, if I say that if my annual disbursement value increases by 10% or maybe 20% from the current value, from the estimated value which I have used in my analysis, what will happen to my decision? Will it turn the positive present worth into negative? Suppose for the given value you find that net present value is coming to be positive. So, by changing this, will my present worth change from positive to negative, and thereby will it change my earlier decision. So, in the earlier decision you might have found that it is better to go with this alternative, but whether by making changes up to this extent will my decision still hold, that is the purpose of reading the sensitivity analysis. Now, you will find that when we do certain problems, you will find that when you make changes in different variables, it may or may not lead to the reversal of earlier decision. So, it may so happen that NPW earlier also is positive, now also with the change it is positive. So, you do not find there is reversal of decision, but in some cases you might find that your decision may get changed. In some cases you find that even if there is a slight change, so maybe 5% change or 10% change in your original value in one variable, it might lead to a reversal of decision. So, for such variables we say that they are highly sensitive variables. So, what are highly sensitive variables? Highly sensitive variables are those variables in which if you make even a slight change, maybe of the order of 5% or 10%, that will change your original decision. On the other hand, there could be some other variables which even if you change them by double, so 100 becomes 200 or 100 becomes 50, you find that there is no change in your original decision, and such variables we call them as not sensitive variables, or sometimes you call them as insensitive variables. Now, what is the implication of identifying these sensitive variables or insensitive variables or not so sensitive variables? You will find that management can focus their attention on those highly sensitive variables, because even if there is slight error in forecast of these variables, you might find that your decision may go wrong, right. So, it is essential for the management to concentrate on those highly sensitive variables, and even if you do not put lot of effort and energy on insensitive variable, it is also okay, because it is not going to change your decision anyway. Now, as far as sensitivity analysis is concerned, it is basically a non-probabilistic technique. When I say non-probabilistic, we are not assigning any probability to different variable values. Say for example, when I say my income is 100,000 and it may go up to 90,000, or in extreme case it may go up to 110,000. So, that is it. We are not assigning that okay, for 90,000 the probability is 1 by 3, 100,000 the probability is 2 by 5 and so on. So, we are not at all assigning the probability corresponding to the different possibilities of these variable values. So, in that sense it is a non-probabilistic technique. We will also like to do probabilistic technique, but in some other lecture where we will assign various probability values associated with different variable values, and then we will see what is the risk associated with a particular alternative. Now, if you try to look at the different forms of sensitivity analysis, this figure captures all the possible forms of sensitivity analysis. Now, we can carry out the sensitivity analysis for one alternative, we can carry out the sensitivity analysis for more than one alternative. Now, in the beginning we will concentrate on single alternative sensitivity analysis. Now, there also you can make changes in one variable at a time. So, here we are changing one variable at a time. So, either we can change income alone at a time, or expense alone at a time, or salvage value at a time, or service life at a time, and so on. In another case, we will change two variables at a time. So, we may take two variables, any two variables. For example, we can take income versus service life, salvage value versus service life. So, we will take two variable and we will change them and then see what is the impact on the original decision. So, this comes under change in two variables at a time. Then in one case we will try to change all the variables at a time. So, more than two variables, or in worst case we will make changes in all the variables at a time. So, what you find here is we are moving closely towards practical situation. If you remember, our earlier assumption was all the variable values what we are assuming for our analysis, they are fixed, they are certain to occur, there is no change. So, whether it was interest rate, even if it was the life for 5 years, we said okay, interest rate is not going to change. So, the salvage value also was not going to be changed. So, everything we assumed it to be certain and fixed, but what we are doing now, we are taking one single alternative at a time and we are making changes one variable at a time, maybe two variables at a time, and more practical, we are making changes in different variables at the same point of time. Likewise, the same analysis we can carry on for more than one alternative also. and there also we can have changes in one variable at a time, we can have changes in two variables at a time, and we can change more than two variables at a time. Now, in sensitivity analysis, we have a tradition of representing the results of sensitivity analysis in different forms. So, for example, change in one variable at a time, we show it with the help of a spider web diagram. We will show you. Likewise, when you are making changes in two variables at a time, we show the results either using family of curves or using isoquants. Likewise, associated with different forms of sensitivity analysis, we have different way of representation. So, we will see each one of them separately. So, in order to illustrate this, whatever we have discussed so far, we will take one small example and then we will explain you how to go about it. Now, you will also find that sensitivity analysis can be performed with any method of evaluation, whatever we have studied so far. It could be present worth method of evaluation, or it could be annual cost method of evaluation, or it could be internal rate of return method of evaluation. Also, this analysis we can carry out at different stages. It could be pre-tax stage. You already know in pre-tax we are not concerned about the taxes. We can also do this analysis for post-tax. Post-tax analysis, you have not been exposed to this stage so far. We will take it up in one lecture subsequently. When we talk of post-tax, in this basically we will consider depreciation and various corporate taxes that are prevalent, and then we will draw the cash flow diagram. So, you can find that all these analysis you can carry out both in the pre-tax stage as well as in post-tax stage. Fine, this already I have told you that the results of sensitivity analysis you can show it either as spider web diagram or isoquants or family of curves. All these we will show you little later. Now, to illustrate what we learned so far and to tell you how exactly we carry out sensitivity analysis for single alternative. Remember, right now we are going ahead with single alternative. Subsequently, we will also go with multiple alternative, but to start with we take a small example, that too with a single alternative, and the data that is given pertaining to this alternative is shown here. It says that there is an alternative in which you have to invest rupees 500,000 at time t is equal to 0. We call this as either first cost or initial cost. So, cost is 500,000. First cost is the initial cost, that means this is the investment that you have to make at time t is equal to 0. Incomings out of this investment is going to be 100,000 every year for 10 years. Outgoings for this plan is going to be 5,000 every year for next 10 years. Expected salvage value is 50,000. The interest rate that is assumed is 12% and the service life is 10 years. Now, all these values, if you remember, so far we had assumed them to be constant. Now, what exactly we are planning to do here is to make changes in each of these variables one at a time. That is the simplest to start with. So, we like to see what happens if my incomings value changes from 100,000 to some other value. Will my original decision change? Similarly, I would like to know what will happen if instead of an estimated outgoing of rupees 5,000, there is some other outgoing. Will it change my original decision? Or for that matter, salvage value 50,000, it changes to some other value. What will happen out of that? Interest rate, instead of 12%, some other interest rate, what will happen to my original decision? So, before we see the impact on our original decision, first we would like to see what is my original decision. So, given this data, what will you do? Will you select this alternative? Will you not select this alternative? First, we would like to go ahead with that decision. For that, as I told you during the lecture, we can find that answer either using present worth method or future worth method or any other method that we have studied so far. Now, in order to find the, let us say we are going ahead with the net present worth value, we would like to first draw the cash flow diagram for this. So, let us try to do that. So, let us assume this is time t is equal to 0. Now, at this point of time we are given we are investing 500,000. The incomings that are expected are 100,000 every year, 100,000 per year for next 10 years. So, this is 100,000, this is year 10. Now, outgoings are also estimated, these are 5,000 every year, 5,000, here also it is 5,000, and the salvage value is given to be 50,000. So, this is the cash flow diagram. Remember, right now we are carrying out the sensitivity analysis only for single alternative, and that too, if you remember, we are going ahead with changing one variable at a time. So, right now for these estimated values, the net present worth is going to be, interest rate as given is 12%, it is going to be minus 500,000, this is all negative, plus 100,000, we want to find its present worth, we are given annuity P given A for 12%, 10 years, minus these 5,000 which is outgoing, multiplied by P given A 12%, 10, plus for this salvage value we will calculate, which is 50,000, P given F, this is a future value, we want to find its value at time t is equal to 0. So, we are using this factor P given F 12%, 10. Now, as far as these factors are concerned, I will give you the value. For P given A 12%, 10, the value is 5.6502, and for P given F 12% for 10 years, this value is 0.3220. So, if you put these values, you will find we are getting a net present worth in positive, which is 52,869. You can cross check them, So, the idea here is we are getting NPW of positive. So, it means we are okay with this investment plan. If we are going with the net present worth criteria, we are getting positive value. So, we will say that okay, this investment of 500,000 which is giving me a return of 100,000 every year, and we need to spend 5,000 every year for next 10 years with a salvage value of 50,000 is worth pursuing. So, this is my original decision, worth pursuing this investment plan. Now, what I will do is I will make changes here. So, this is my fixed value for the calculation of NPW now. What I am thinking of doing it now is I want to find what will happen to my decision if, let us say, instead of this 100,000 per year assumed value of income, if it becomes 90,000. Will my decision still hold good or will my decision change? Let us try this. So, what I do? I make these changes here. I calculate net present worth like this now, it is minus 500,000, no change here. Now, instead of 100,000, now I am writing 90,000. Here again it is P given A 12%, 10, minus 5,000, this is outgoing, P given A 12%, 10, plus 50,000 which is salvage value, P given F 12%, 10. So, you will find that we are getting a minus value minus 3,632. So, what you find here is that with 100,000 incoming, we were getting a positive value, whereas with 90,000 just 10,000 drop in income and you find you are landing in a negative value. So, now with this value your decision would be not to pursue this investment plan. So, what you find? You found that even if there is a 10% reduction in my income from the projected income, my decision changes from acceptance to rejection. So, we can say that this is a very sensitive variable because it can't sustain even 10% change in its value. So, this is a highly sensitive variable. So, this is your incoming. Now, in the same manner I can do this exercise for outgoings, I can do this exercise for salvage value, I can do this exercise for interest rate. So, I can take each of these variable one at a time and make changes there. Now, if you do this exercise, you will find that some of the variables are sensitive, some of the variables are not. Now, this is very important conclusion, because the moment you understand that okay, this variable is very sensitive, you are going to be very careful about the estimate of that particular value. Sometimes if you find some variable is highly sensitive, you may even think of hiring a consultant to give you those values, because those values are very important. Slight change in the value here and there and your decision is going to change. So, you need to spend time and money, effort to forecast those values very accurately. Now, this exercise, instead of doing it in absolute terms, we can also do it in terms of percentage. So, what you can see here is that I can assume that let us say the variation in incomings is x. So, instead of changing the value from 100,000 to 90,000, I might do this in form of percentage. So, I will say let us change this variable by x percent, and what happens to the net present worth corresponding to that percentage change. I would like to find for what percentage change in incoming my net present worth becomes 0, because that point 0 will be the point at which the net present worth changes from plus value to minus value. So, it is very important for me to understand where does the 0 lie. In fact, the importance of 0 is realized, and we call that value where you are getting 0 as break even point. We will have a detailed discussion on break even analysis, where our main focus would be to find that break even point, where your decision reversal takes place. Your net present worth changes from plus value to a minus value, right. Instead of finding the changes in terms of absolute value, you can also find the changes in terms of percentage. So, for example, you can very well find it out that if the incoming value decreases by 9.35%, so 100,000, if it decreases by 9.35%, you will find the net present worth turns out to be negative. So, this 9.35% change itself is causing the change of decision. Likewise, we can find similar percentage for other variables also, and you can plot them in the form of a spider web diagram. So, this is what is known as spider web diagram, right, and the results of single variable change for a single alternative, we are showing it like this. Now, you can see this particular value here is corresponding to change in the incomings value. You can see this line is very steep, you can see this slope is very steep. Now, this represents that this variable is very sensitive, as we have found it out. You can see that even if there is a drop by 9.35%, you can see this 0%, minus 5% and minus 10 is here. So, even if there is a drop of minus 9.35%, your decision changes. So, till here your net present worth is positive. So, net present worth is on this scale. So, all these values are positive here, and below this they are negative. So, the moment there is a drop in excess of 9.35% in the incoming value from your estimated value, you find your net present worth changes its sign from positive to negative. This exercise you can carry out for individual variables. For example, this one is for the interest rate. You can see here also interest rate slope is very steep. So, this is also a very sensitive variable. You find that even a slight change in the interest rate, right now it is 12%, you may do this exercise for 10% or for that matter 14% and then see what is happening. So, you will find that even if there is slight change in the interest value, you will find that your decision changes. But when it comes to these two variables, if you see here outgoings and salvage value. So, these two lines are corresponding to outgoings and salvage value. So, this one is for salvage value, the triangular one salvage, and the other one is for outgoing. So, you can see the slope for them is very flat. The flatter slope represents that they are not very sensitive, almost insensitive. So, there is no point putting too much attention, too much focus in estimating these variable values. Even if you are approximate, it should be all right, because they are not having a great impact on your overall decision. But when it comes to incomings and interest rate, you find even a slight change there may change your decision. So, this is what you have to understand it very carefully. So, this is what it says, the variables incomings and interest rate are very sensitive, while variables such as outgoings and salvage values are less sensitive. How do we do this? The same problem, what you can do is, instead of now 5,000 outgoing, we can take it as 10,000. So, we are just saying okay, this 500,000, we are not changing this, 100,000 remains 100,000 itself, but this 5,000 we are assuming, let us say it becomes double, expense becomes double, and there is no change in salvage value, there is no change in the incoming value. So, this 10,000 still remains 10,000. Now, this is year 1, 2, 3, year 10. What you find is that instead of 5,000, now I am making it 10,000. So, if you calculate the net present worth for this situation, my net present worth is going to be minus 500,000, no change here, plus 100,000, P given A 12%, 10, minus 10,000, P given A 12%, 10, plus this is still 50,000, no change here, plus 50,000, P given F 12%, 10. Let us try to do this, how much this comes out to be. So, this is minus 500,000. Now, I multiply 100,000, these values are 5.6502, this is 5.6502, and this value is 0.3220. So, I can calculate this minus 500,000, okay, we do this like this, 100,000 multiplied by 5.6502 plus 50,000 multiplied by 0.3220 minus 10,000 multiplied by 5.6502 and minus 500,000 is coming out to be positive, it is 24,618. You can cross check this. So, the idea is that we are still getting a positive value. So, you find that even if I am changing the expense by 2 times, 5,000 I made it 10,000, still I am getting a net present worth of positive. So, that means even if I am changing this variable value to double of its current value, my decision still remains same. So, we say that this is not so sensitive, in fact, this is an insensitive variable, right. So, this is how you have to carry out the sensitivity analysis. If you remember, we have carried out the sensitivity analysis only for single variable and that too for a single alternative. In the subsequent lectures, we will discuss single alternative more than one variable at a time. Then we will also discuss more than one alternative There also we will see single variable at a time, more than one variable at a time. So, just to summarize, in this lecture we discuss sensitivity analysis, which is basically aims at finding the impact of my original decision for a change in my original variable values. So, I would like to see what happens to my original decision if my income changes from original x to x plus delta x or x minus delta x, if outgoing changes from y to y plus delta y. Likewise, I am going to change these variables and I am trying to find its impact on my original decision. The significance of this analysis is in understanding which variable is sensitive, which variable is insensitive. Why I am trying to do this is because for the sensitive variable I will put more focus, I will put more energy, so that I do not make mistake and I do not land up in change of decision or change of plan. So, this is one very important exercise we must carry out in most of the situation. In the subsequent lectures, as I told you, we will discuss more details on sensitivity analysis, but till then we stop at this point and see you some other time. Thank you very much.